Good morning. Bonjour. Okay, so we have like maybe 3 or 4 people alive. So today, really, I wanted to talk about Java serialization from a security perspective, and also how to fix it. I don't know how many developers here, Java developers. Okay, perfect. So that's right for you. So I've been working in this area for many years, and I keep finding security issues with it, and that's why I wanted to present today. So I will quickly introduce what this feature is, and then we'll talk about how to abuse it, the attack vectors. And I want to make a difference between what we call gadgets and what I call endpoints. And for each of them, I'll give you a demo. And then in the second part of the presentation, we are going to talk about how to fix this. Again, fixing the gadgets versus fixing the endpoints. And another demo will be shown. And basically, the idea is that I will bypass my own mitigation that I found a couple of years ago when I was working with Trevor. And because this can be bypassed, I want to introduce today a new way of mitigation, a new mitigation for this. So, a little bit about me. So I have 10 years of experience as a Java developer, and after that, I moved into application security for another 10 years. I do a lot of code reviews, and this is how I found vulnerability in all these products. What else? I'm also a mentor for OWASP in Ottawa. You can reach me on Twitter, on LinkedIn. Talking about URL, also at the bottom of each slide, you have a URL that will take you to this slide, the source code, and the videos. It's live as of this morning. And yeah, and also I speak French if you want to talk to me after, if it was not obvious yet. Quickly, slide about my employer. I work for Salesforce Trust Team, so that's our security team. And we have a blog where we talk about security research, and I wanted to point that out. We put the vulnerability we found in there, some cool stuff we're doing, tools. And also we are currently hiring. We have several positions open for application security, different geographies, different level, different kind of application security. So talk to me or contact our recruiter here. Okay. So with that being said, let's talk about what Java serialization really is. So last night, I realized, talking to some of you, that for the younger audience here, you might not realize who this guy is. So this is Duke, the Java guy. He was very popular in the 90s. And today he's dressed up as Bonhomme Carnaval. I don't know if you realize. So this is like imagine this is our instance. This is our object. And serializing it means simply transform that object into bytes, into binary. And as you see at the bottom here, something interesting is the ACED05, the first 4 bytes. This is kind of a signature. If you see that going during a pen test, that means that this is serialized Java. So something to remember. And obviously, deserializing is the opposite. You take some binary, and you create an instance from it. So again, from an attacker perspective, the deserialization is what we are looking at. So the attacker will serialize something malicious, and then the server will deserialize it. And this is what we are going to talk later on. So it is used for persistence. People use it to save objects into files, into databases. It's used for transmission as well. RMI is another feature of Java. It's called remote method invocation. There are other things, other endpoints there where you can send your Java serialized string. For instance, Spring HTTP Invoker is one. And from an API standpoint, you serialize by writing to an object output stream, and you deserialize by reading from an object input stream. So Java knows how to handle, the byte, the integer, all the primitive types, and it uses reflection and unsafe to handle everything else, every other classes you might have. But not every class is serializable. The designer of the class, the developer, must explicitly implement this interface Java IO serializable. So now let's look into how we can abuse that. So far, I mean, you're probably wondering, hey, what can possibly go wrong with that? There is one specific item, a part of this serialization feature for Java that you can abuse is that the designer of this feature, they imagined that they wanted to give some liberty to the developer. So they came up with this idea of write object and read object. So if you're a developer and you have a class that you want to make serializable, you can potentially declare this write object and read object method if you have something special to do. And I'll give you an example. Big Decimal is part of the standard Java library. It's not really readable, but they have this read object method just to do that, right? So the read object method takes an object input stream as an input. And then the first line they do, they just call default read object, which is like saying, handle this like the regular way. But then after that, they wanted to add some input validation. So you have a line that says, if int val is null, then I do something specific. And this is typically the way it's used. So the int val member is instantiated via the regular serialization. So all that is to say that these read object methods, they are always called when you deserialize classes that have one, right? And we are going to abuse the side effect of this because whatever is inside this read object method on the server will be called when the remote attacker try to deserialize an instance of that class. So an application is vulnerable if it deserializes untrusted input, and you have an existing class on the server that has such a read object method and that does something in it that you can abuse. So they can be chained. For instance, I'll give you an example. A couple of years ago, I found one in OpenJPA where I found one class with a read object that inside the read object, I was able to redirect the standard output to a file. And then I found another class that has another read object method where I could write anything I wanted into the standard output. So these two put together, I was able to create a JSP file on the server, and I was just able to remotely trigger the JSP file. So that was a remote code execution. And people call them gadgets in reference to ROP gadgets. It's slightly different, but it's like kind of the same idea because you reuse what the server already have. And I'm talking about read object, but we'll see later that there are other methods that share the same properties. And collectively, we call these the magic methods. So sorry, this is a little bit of an eyesore, but I really wanted to put that up for two reasons. So this is all the talks and all the vulnerabilities that have been reported in that specific field. And I want to call out the first row here. A gentleman called Mark Schoenfeld, more than 10 years ago, basically did the same presentation I'm doing here, presenting the same risk and identifying the problem with this feature of Java. And all that to say that it's not new. I mean, it has been more than 10 years old. But recently, the fall from 2015, people like Matthias Kaiser and Chris Brohoff and Gabriel Lawrence and others, they were able to, and they were successful in reviving this forgotten attack vector. And I'm thankful for that because this year, pretty much every security conference has a talk about Java serialization. So that's good. And also the last row, Wouter Koekoorts did something really interesting. he came up with a gadget that is based on a hash set. So if you know Java, you know that a hash set is a very common class. We use it all the time. And he found a way to construct a malicious hash set that, once deserialized, will trigger a denial of service. So the reason I'm mentioning it, because I'm going to use his gadget several times later in this presentation. So what do I mean attack surface endpoints versus gadgets? So imagine in the middle here we have our vulnerable application, and the vulnerable application accepts untrusted inputs and deserialized it. So our attacker was able to create some binary on his own computer, and he's going to send that to the vulnerable service. So the attacker doesn't really know what classes are available on the server, but it's just taking a guess that a class called vulnerable is maybe available on the class path on the server. The vulnerable service just takes the input and deserialize it. Of course, they don't accept vulnerable. They are expecting bottom comma value. So from a code point of view, it looks like this. You call the read object method on the input, and then you cast it to your legit classes that you are expecting. Then the Java virtual machine will just load the class, but it won't load what you're expecting. It will load what the attacker has specified in the binary, right? So vulnerable in this instance. And if vulnerable has one of this magic method, Java will automatically call the read object method, and the attacker will be able to execute whatever is in there. So note that there is a cast in the application level. Once you've deserialized the object, the developer, they cast it to the legit classes, but that's already too late. They will get a cast exception, but the read object method has already been executed, right? So this is how we abuse this. So target number one here is what I call endpoints, right? And target number two is what I call gadgets. So obviously we need both, right? When you want for a successful exploit, you need one and two, right? You need an application that takes arbitrary inputs and deserializes from it, and you need some classes on the server that has unsecure magic method. So now let's talk about the gadgets themselves. So that's our number two target we had before. So a class is vulnerable if it has one or more magic method, right? And so what are there? I talked about read object, but there are more. We have read resolve, validate object, read object no data, read external, and finalize. So finalize, if you know Java, is like the destructor, right? So just before the object is garbage collected, if you have a finalize method implemented on your class, whatever code is in there will be executed. So that's another magic method. But I haven't put constructor here. We're talking about destructor, but the constructor is not called when you deserialize, right? So if you have a class that does something malicious inside its constructor, you won't be able to leverage that when you deserialize it, because Java uses unsafe, which is the name of a feature in Java, to create the object, as opposed to calling the constructor. So what do we mean by abusing a magic method? So I already mentioned that anything that has a side effect that you could abuse, right? So think of creating a file, accessing network, code injection if you're lucky, denial of service. Etc., etc., everything you can think of. So let's jump into my demo here. So Java memory exhaustion, that's what I'm going to present. So imagine we have such a magic method here. First line you see here, we read an int from the stream that is controlled by the attacker. Again, everything is controlled by the attacker because the attacker creates the binary on his own computer and then sends it to the server, right? So this int that is read from the string is controlled by the attacker. And then the second line right after, imagine that the server instantiated an array of whatever of that length. Then that's a very easy way to use that all the memory, right? And guess what? I found this all over the place. It's everywhere if you look for it, like in the Oracle implementation, in the class library, in Tomcat. It's everywhere. So I just created a little application here where it created a couple of such payloads, and you have a menu here just to try, and you can deserialize each of them. And in each of them, you will see that you have a out of memory error being thrown, and in each case, it gives you which classes is vulnerable. But I mean, if you look for this, you will find many others. So this was an example of a gadget that creates a denial of service. So what about the endpoints now? So an endpoint is vulnerable if it takes untrusted input and deserializes it, right? So from a code perspective, if you guys are doing code reviews and you want to find these vulnerabilities, this is what you need to look for. So we create an object input stream that is eventually built on users' input, right? So it can be reading from a file. That would be obviously more difficult to exploit, but it can be read from a post request. It could be read from a cookie, like we've seen with IBM WebSphere. Everything that you could control as an attacker. And then calling read object or read unshare on that object input stream will trigger the deserialization issue. So let's move to our second demo about an endpoint. So I reported that to Oracle earlier this year, and it has been fixed for more than 6 months. And that's why I'm more comfortable presenting it today for the first time at this conference. So JMX is another feature of Java. It's called Java Management Extension. So it's an API for managing and monitoring resources, right? So think of it like the SNMP of Java, right? It has 2 optional features, TLS socket and authentication. Really important. Authentication is really important if you're using JMX. So this example here shows you how it looks on the client. If you enable authentication on your server, the JMX client will just prompt the user for username and credential. Simple, right? So why is this important? Like even before this specific vulnerability I found, JMX already had known issues. So prior JMX vulnerability, just abusing existing features. This is an example of Tomcat. So fortunately, Tomcat doesn't enable JMX by default, so you have to change your config to do so. But be aware, if you do so, be careful, bind to a local port as opposed to binding to a remote accessible port, and enable authentication with strong credential, because you have features like this. So basically that's your JMX client, and on the left you have a couple of mbeans, they are called, and you click on it, and then you can call a method on it called list session IDs, and suddenly you have all the session IDs. So what can you do with this? Just copy and paste into your browser, and you can impersonate anybody else. Pretty interesting. Another very well-known vulnerability, and there is even a Metasploit module for that one, is the remote code execution with mlet. So again, it's only vulnerable if authentication is not enabled, or if you can guess the password, or if you can brute force the password, obviously, right? So we are victim.com that has a JMX listener open to the internet, and then our attacker on evil.org is able to connect. So that's the precondition. Then the attacker called the create mbean on the JMX listener, and he creates mbean of type mlet. And the mlet allows you to specify a URL from which the code will be loaded. So it's like a remote code loading. So evil.org is a domain that the attacker controls, and he had put an evil bean on it. And then victim.com would just download whatever code from evil.org. And then we just need to invoke, and whatever implementation we put into the evil bean will be executed on the server. So that's pretty bad. So going back to my new vulnerability now. So a client needs to connect to a server. So the clients need to know some kind of addresses, right? We call these JMX connection strings or JMX URL. And it looks like this. So two things. There is a JMX part, right? Followed by a RMI URL. So that's our JMX endpoint. And then we have another part, JNDI, which is Java naming directory interface, also followed by a RMI URL. That's our naming registry. So how many times did you see RMI in the URL? 2? Depends how you count, but yeah. So the idea is that we see that this is like a symbolic high-level URL that encapsulate RMI URLs. So the idea is that they wanted the JMX connection string to be transport layer agnostic. They wanted it to be future safe. They wanted to make a URL so that you can use other transport as well. But as far as I know, I've never seen any other transport that RMI. So my idea was, why not try to bypass the entire thing and connect directly using RMI to the JMX server? And that's what I've tried to do. So on this slide now, on the top is the same URL you're supposed to use to connect to the JMX server, but I created a short version in Java, which is basically a typical way of using RMI in Java, right? So you first locate a remote registry with a port and a host name, and then you just look up a symbolic name, JMX RMI, and you cast it to whatever interface you're expecting, RMI server in this instance. And then you can call the new client method on it, and you pass in your credential by way of an array of 2 strings, the username and the password. So that basically is equivalent of using the very long convoluted but future safe JMX connection string, right? So what is RMI again? If you remember, I mentioned it is another feature of Java that relies on serialization, and it's client server. So it's like an RPC for Java. So if you look at the network, imagine we have a JMX client talking to a JMX server. That's what you will see. So 50 is for RMI call, 51 is for RMI response. And after that, what do we see? Our usual suspect, right? The ACED 005. And it's just a regular, if you just remove the 50 in the front, it's just a regular serialized string here. We see our array of strings, and we even see our credentials being passed here. So my idea really was, this is a definition of an endpoint, if you were following me, right? Because we have a client that can set arbitrary binary to a server that will deserialize it. So my idea was, hey, let's try to change the binary and so that I will replace the array of string with something malicious, and then the server will receive it and will deserialize it. But the beauty of that is that I didn't even have to do this because there is a Java API for doing just that. So if you look at the RMI server API, that's what we use to call the new client method on, right? If you look at the new client method where you passed in the credentials, it's not strongly typed. It's an object. It's not a string. It's not an array of 2 strings that they're specifying here. It's just an object. So you can just, on the client, create whatever object you want, call the new client on the remote object, and that's your unsecure endpoint. And the beauty of this is that even if you enable authentication on the server, this happens before because you're just sending your credentials, right? So the server needs to deserialize the credentials first to just try to authenticate you, right? So let's look at the demo here. So I'm using Tomcat, but again, the vulnerability is in Java, not in Tomcat. So I'm using Tomcat with the vulnerable version of Java. I'm bringing up another computer as a client. And here, I have a little application that you can download that tries to connect to the remote server. And it tries to connect using 3 ways. First is the long URL I mentioned. Second way is the short RMI shortcut using passing the string of the array of toString. And the last one is the maliciously constructed hash set from Barbara Cookert instead of the string, instead of the array of string. And the server is not responding. Why? Because the server is too busy processing the request. So now I'll show you how they fixed it. Now I'm restarting Tomcat, and this time I'm using it with a version of Java that has the fix. So it's Oracle Java 8 update 1.1. And trying the same thing again, connecting 3 times during 3 different ways. And we see an exception this time. We see that the 2 first one went through, but the last one, we got an unsupported type Java util hash set. So they implemented some sort of validation, which is good.
They just blacklisted the hash set?
No, they whitelisted. I'll come back again. That's a good question. But though they're explicitly expecting 2 strings now. Anything else will not be deserialized. So now it's time to move to our second part, and we're going to talk about blacklist and whitelist. So how do we protect against this? So before I go into details, I've seen this year on Twitter some pretty nasty blame game going on, and even on other security conferences. So the question is, where do we fix it? Remember, we have our 2 endpoints, the target number 1 and the gadgets target number 2. Which one, where do we need to put the fix in, right? So some people say, oh, an application should never deserialize untrusted input, right? Like JMX doesn't do that. And then some other people say, well, all the read object method we have, and they should only do simple things that people cannot abuse. So it's an open question. But if you ask me, my personal opinion, I mean, it's really a no-brainer. We should fix it in both places, obviously, right? Have you ever heard of defense in depth, layered defense? You know, that's what we tell people to do. So we should fix it in both places. So how do we fix it at the gadget level? So we could make the magic method more secure. So what does that mean? Some fixes I've seen over the years that some people realize, oh, maybe these classes, it has so many side effects that maybe I should just remove the implement serializable, right? And then if you don't make it serializable anymore, there is no problem. Or we can add input validation. That's an interesting concept, but it's, you know, if you think of a typical web application that has a web form that you send data to the server and the server processes the data. I mean, we all know that developers, they always do input validation, right? It's always validated. Most of the time they do, because it comes from a web form. So why should it be different if the input comes from a stream of binary? And why don't we do input validation on the first line of the read object method, right? There's nothing preventing us from doing that. So for instance, if you were handling files in that read object method, we could just, you know, make sure we don't have path traversal. if we are creating files or if we are creating a new array, we could just make sure we can restrict the resources, we can catch the exception early, a lot of things we can do. So that's the easier part. Now, how do we mitigate against endpoints? So obviously the best fix will be to change the API, right? Because right now we have this, if you remember, right? We call in the read object, and then we cast it to what we are expecting. Wouldn't it be nice to have another method where we call the read object, but then we pass in what class we want, right? And then we don't even have to cast. But again, I mean, some people don't know what they're expecting, right? I mean, for instance, message queue. A few message queue have Java serialization as a transport mechanism. So they don't know what they are going to be sent. And also knowing the developers, I mean, the first thing they will do, they will call read object, object.class. Okay, I have no error anymore, it compiles. So, and anyway, that's not going to happen soon. So we need something else. Another idea will be to use sandboxing. So what we mean by that is that we take the code that does the deserialization and we put it inside a block that is protected by a security manager. So a security manager is another feature of Java where basically you control what you allow the JVM to do, right? So for instance, we could configure the security manager not to access files, not to create a process, etc., etc. Whatever you deem unsecure for your own use. But it's not recommended for two reasons. First reason is that, again, if you don't know what you're expecting, it will be a real nightmare to configure it, right? You will never know what you should prevent and what you should let go through, right? And then for another reason, like it doesn't work because look at the CV I found a couple of years ago. What I was abusing was inside the finalize. So imagine this: you deserialize the input, and everything is fine. You have a security manager; it protects everything when you deserialize, and then the object, has its life. And at the end of the life cycle of the object, when you don't use it anymore, it's going to be garbage collected, and then the finalize is called by Java. That's outside of the block protected by the security manager, right? So it won't help in that case. For instance, this is an example of finalize that deletes a file that can be controlled when you deserialize. So it has some value, right? But doesn't protect from everything. That's why in 2013, I came up with this concept of look-ahead Java deserialization. So at the time, I looked at the class name, right? So it's today, I'm really glad that it is used by a lot of tools, Serial Killer by Luca Carettoni, Contrast as a really nice agent-based one based on this idea. And there is even a JDK enhancements proposal, a JEP, that proposed that we use this, and CERT as a secure coding guideline suggesting that you use this idea. But it's not that good, and I will show you why. So let's look at the object serialization protocol. So it's a protocol in the sense that it's used for parsing the binary, right? So as already mentioned, the ACED 005. So we have something called stream magic, is a kind of a header. We have the version of the protocol. Then we indicate that it's an object that is serialized. And then we have our class description header. That's what we are interested in, because the class description is followed by the class name. So length, array of character. Then we have a unique ID, some flags, and then we've done parsing the metadata. Now we are going to parse the data, so meaning the fields, the value. In this example, it doesn't have any. Anyway, by now you should have realized two things, right? One, I really like PowerPoint animation. And two, we already have what we need, right? We already have the class name that the malicious attacker is sending us. So again, my idea was that, okay, this is great. I can write my own binary parser, and whenever I see the class name, I stop and I do validation. And implementing your own binary parser is always secure, and let's do that. But I realized I don't have to, because there is a Java API just to do this. So the idea is that you can create a callback that will be called by the virtual machine just before deserialization happens. So that's exactly what you want. So all you need to do is you create your own class that is a subclass of the object input stream that you're normally using for deserialization. And then you override a method called resolve class. And resolve class just gives you as an input the object stream class. So in this example here, I'm calling the get name on the class description, and I'm just validating based on the name. If it's Bonhomme Carnaval, if it's not Bonhomme Carnaval, I'm throwing an exception. If it is, I'm just proceed normally by letting the superclass handle it. So going back to your question, blacklist versus whitelist. So as with any validation, you have two ways of doing it, blacklist and whitelist. So whitelist meaning you explicitly list the class names that you're expecting, and they don't have a side effect. You know that you looked at the code, they don't have any malicious read object, and you let them go. That's good, but again, in an enterprise scenario, one, you might not know what you're expecting, and two, you might need to open up to so many that it kind of kills the purpose, because they might have side effects that you don't really aware of. And then you can use blacklist. So blacklist meaning you're only preventing known bad class names. So of course, this is easy to do for a developer, really bad idea for security, because we know a few classes there that have gadget classes that are serious consequence if you deserialize them. But we don't know them all. And also, it's known to be broken because Alvaro Munoz and Christian Schneider, they came up with this idea of a class I call a springboard class, because if you look at this class, inside the magic method, they instantiate their own object input stream and they read from their own. So even if this class is protected by your callback that you can validate, inside they basically bypassing it because they create their own object input stream and they read from that. So you will lose your validation hook, let's say. So let's look at the demo here. So not only they came up with this example, they also found real implementation in the wild. And they contributed these two first one to the Weiser serial. Weiser serial is a repository on GitHub that has all these known gadgets. And I found a third one, but it's the same idea. You see exactly that, right? They have a read object, and they instantiate a subclass of object input stream, and they read twice from it. So let's look at the demo here. I'm using Apache TomEE, which is a enterprise J2E implementation. So I'm bringing up my client computer, and I'm checking the version number. It's 173. So now I have another application that generates a payload, generates this file. And now I'm going to send a post request to the server using the data from this file, because every Apache OpenAGB has a /tomee/egb URL that you can post binary serialized data to it. And the server doesn't respond. Why? The server is too busy processing the request again. So now we are restarting the server and using a next version of Apache TomEE. Wait for a second. Sorry. So just checking the version number. So it's one version up, and we try the same thing. We try to send the same post request. At this time, our attack didn't work. There's no denial of service. We check the log file, and we see that they added some validation here. Security error hash set is not whitelisted as deserializable. So they have a config file, system.properties, where they have two lines, one for blacklist and one for whitelist. And by default, they blacklist everything, and they don't whitelist anything. So I'm changing that to blacklist only hash set, and to whitelist a few things like our legit use case, Java.everything, and Apache.everything. Then I start again. I try again, and again, it didn't work. No denial of service. This time, it's not because we blacklisted everything, but it's because we explicitly send the hash set which has been blacklisted, right? So that's good. Now I'm going to use the same program to generate the binary, the payload, but this time I'm going to use this springboard idea to try to bypass it. And I'm sending it again with a post request. The new file I'm using this time. And the server doesn't respond because the server is too busy processing our denial of service. So what we've seen here is that Apache Tomee is secure by default because they don't allow any serialization. You can change that, and we've seen that I was able to bypass the class name validation because I found another class that I could bypass the class name validation, basically. But an easy fix would obviously to blacklist as well these other classes, right? And that will, I will go back to your question later, and that will fix it too, right? All that to say that class name blacklisting is hard. That's why I came with this new idea of having a look-ahead method blacklist. So blacklisting class names may be impossible because you don't know what to blacklist, but maybe you have a very good idea of method call you want to blacklist. Maybe you know perfectly well that you don't want to allow file access, network, etc. So I came with this idea. So it's the same idea of this validation hook that is called, but instead of looking at the name, we look at the bytecode, right? So the first idea is that if the class doesn't have any magic method, then we're good to go because there is no side effect. We can just deserialize it. But if it does, then we need to look at all the magic method, look at the bytecode, look at kind of build the call graph of every method that is called from these entry points, and then compare that to your blacklist. And if any blacklist method call is found, let's say you don't want to create a file, and then your blacklist is that any of the blacklist, you reject it. That's basically the idea. And I've released the code this morning at the URL below. Check it out. I implemented it in a way that you can bring your own bytecode library. So check it out. So I guess it's a time for my conclusion here. So we talked about different ways of mitigating against these attacks. So using the security manager is not a complete solution because it can miss some cases, right? Using my original look-ahead class name validation using a whitelist can be a solution if it's really restricted. But the blacklisting, I don't suggest you do that. And if you really have to use a blacklist, you might want to try this new method blacklisting. And then bringing the conclusion to my conclusion is, if you're a developer, and some of them are, just don't use serialization because I hope I was able to convince you that it's a risky proposition. um, and if you really, really have to, like let's say you cannot use JSON or you cannot use more safe and more secure alternative, try to use class name whitelisting. And if you really can't, try this method blacklisting. But again, try not to use it at all. And with that, I have a few minutes for questions. Sorry, what's first? Oui. So the question, yeah, the question was the URL of the OpenAGB where you can send arbitrary. Yeah, there is a legit use case. It's the OpenAGB implementation they have. They've been using it for a while, and like it's a product that has this feature. People start using it. So after a few years, it's hard to say, oh, we don't use it anymore.
In the renewable, the classic renewable code, some code called read object, then there's a cast.
Yep.
The cast comes too late, which basically the problem. But in the calling by code, you get an invoke from the method, then the cast of code. Have you considered using a specific class loader when you load that code to detect that it is going to use read object set cast? That information to validate upon the serialization that the incoming class is really the good one.
Yeah, it's an idea, but so the question was, can we use a custom class loader, and in the case where we know what we're expecting the next class to be loaded to be what we're expecting, right? That would work, but again, not for the finalized case. Because the finalized, we don't know when it happens.
The class loader would invoke a special alternative to read object. It would move it aside, wait, and it would send as parameter the target class. That is,
yeah.
First, the target class that you API change proposal, and since it's an API change, it don't have that program. But then it would abuse the classic pattern of vulnerability to do it without an API change.
Yeah. I think the contrast product just does that. Yeah. That's it? Oh.
In the project that we were using serialization and we were not able to just remove it immediately, what we did was essentially to sign it. So what I get, that's not a signature, then
yeah.
Thank you very much.
You can do signing if you control the client and the server. Yeah, that's another point. Yeah. 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 Merci.